Hello guys, welcome back. So in this lecture, let's quickly understand about the linked list and the singly linked list. Okay, so let's go through the definition first. So the linked list is a linear data structure that contains sequence of elements such that each element links to its next element in the sequence. Find each element in a linked list is called a node. Okay, so let me tell you what it is. So the way you have elements in the array, right? In the linked list, we call them nodes. Okay. So in arrays, we have elements like they are stored in their particular indexes, right? For every element, we have some indexes in the arrays. In linked list, we don't have any indexes at all. So all the elements, or we can say all the nodes, are connected to each other, uh, like we can say by the reference. For let's say we have three elements. Okay, the first element will be connected with the second element, and then second element will be connected to the third element. There will be no direct connection between the first element and the third element. Okay, so there will be a middle element which will be connected to the first element, and then that middle element is connected to the last element. So linked list are the linear data structures. So in case if you want to access some data in the linked list, okay, so you have to go from this sequence only, from the starting to the end, or we can say from the head to the tail. Okay, so in linked list we have the head and tail. Head is simply the first element, you can say first node, and tail is simply the last node. Okay, how we decide whether we have which element is the head and which element is the tail is the question right now, right? So the element which is referencing to nothing, okay, the element which is referencing to nothing, that is the last element. We consider that as a last element or the last node. Okay, or we also say like this particular node is referencing to null, okay, or no value. So that particular element we consider as a tail or the end of the linked list, right? So the element which doesn't have any previous element, the node which doesn't have any previous node, okay, but it have the next node, okay, so that node is connected to the next node. That particular node we call the head element, because that node doesn't have any previous elements, but this node have the next nodes, right? So that is why that particular node we call the head node, or the starting point of the linked list. Okay, yeah, so now let's quickly see the definition of the singly linked list. So a singly linked list is stated as the unidirectional linked list. As a result, it can only be traversed in one way, from the head node to the tail node. Head node you know already, or let me quickly write it down. Head node doesn't have previous node, okay, but the next node. Okay, so let's talk about the tail node as well. Doesn't have, or let's quickly pick it. It have the previous node but doesn't have the next node. Okay, so these are the things. Head node will not have the previous node, tail node will not have the next node. It's simple as that. In linked list, all the elements are connected to each other by the next node's reference. Okay, so let's say we have 3-4 peoples. So the first one will be connected to the second one will be connected to the third one will be connected to the fourth one. Okay, so that is why we call it unidirectional in terms of singly linked list. Okay, so singly linked list is like that only. In singly linked list, we can access, if you want to access the third element, you have to go from the first, second, and then third. You cannot access randomly the third element the way we used to do in the arrays, right? We simply use array at position 3 and then we access the, or array at position 2 and then we access the third element, right? We cannot do that in the singly linked list, right? So that is why it is called unidirectional. In case you want to access any node from the linked list, you have to start from the start point or from the head. From that, you have to move all the way up to the element or all the way up to the node which you are trying to find. Okay, that is why it is called unidirectional. It is from head to the tail in one direction only. Okay, we also have like a doubly linked list, which where we can access the elements from the head to tail and tail to head, where all the nodes are connected to each other, we can say, in both the directions. Okay, not from just head to tail, they are connected from the tail to head. But more on that we'll discuss on the next or future lectures, right? Yeah. Now let me quickly show you like a diagram in the visual algo, so how it looks. As you can see, here we have the element side. We call them nodes in terms of linked list. Okay, because they doesn't have any indexes stored in them. Okay, these nodes, whatever you are seeing, the data which you are seeing here, they does not have any indexes stored in them. Okay, so we don't know how big this what to say linked list is, or how small this linked list is. Okay, so the head, we call this one as head because this one doesn't have any previous node, and we call this one as tail because this one doesn't have any next node. Okay, that is how we identify which node is the head node and which node is a tail node, right? Now if you see, all the nodes are connected to each other. Okay, so this one is connected to 2, 2 is connected to 77, 77 is connected to 6, 6 is connected to 43, 43 is connected to 76, and so on, right? So in case if you want to search for 43, what you have to do? You have to come from head and you have to go all the way up till like 2, 76, 6 and 43. Then only you will find this particular element. It is not like arrays where you can simply pass the index and you can search that particular element. Okay, it's not like that in the linked list. Okay, now in case if you want to add or remove some elements in the middle, then also you have to start from the beginning and then you have to move all the way up till the element where you have to place that particular index, that particular node. You insert it and then you continue, right? So this is what we call a singly linked list because it is just unidirectional. It is flowing in one direction only, from the head to the tail. Okay, so this element doesn't know who is the previous node of it, in simple words. Okay, this element doesn't know who is the previous node of it, but this one knows who is the next node of it. Okay, because this one is connected to the next node, right? Now let's quickly search for the 6 in this. Let's see how it works, right? So let's search for value 6. Let me see what happens. Okay, and guys, just ignore this pink and yellow part. Let me quickly close it because this will just confuse you guys, right? Okay, so as you can see, it is starting from the head part. It is moving to 2, 77, and then it will find this 6. Okay, let's play it. Right, so this is how it used to find the elements in singly linked list. This is how we used to find the element. It doesn't matter if your element or if your node is at the end as well, then also you have to traverse it from the head and then you have to move all the way up till the end, right? Now let me see, let's see if we can insert any element in between. Okay, in head we can, head is a just, it's just a straightforward thing. Let me add let's say 11, okay, at the in the head part. So basically the first element. Then let's see what happens. See, it was simple as that. Okay, we simply added the node in the first element. There was no other element before this one, so we simply have added this one as the first element or the head part. Okay, now let's remove the element from the, or let's insert the element in between. Okay, not tail, specify in between. So let's use the index 0, 1, 2, 3. Okay, let's try to insert some element at the position 3. Okay, let's try to insert 121. Okay, and let's see what happens. Okay, we cannot pass 121. Let's use do we have 3 here? We don't have 3, right? So let's use 3. Okay, so now, or wait guys, let me quickly collapse it. Yeah, now just have a close look like how it inserts the element or how it inserts the node in between. We have to insert, we have inserted the element in the index number 3, 0, 1, 2, 3. It must be like at this position, right? So let's see, position 1, position 2, position 3. So here, okay, so I think I have passed something else. Let me quickly see, insert the element. specify both index 3. Let's pass index 3, and then let's pass 3 itself. Okay, now if I click go, 0 1 2 3. Okay, so here it found the position, like at position 3 we earlier we had 77. Now what it did, the second like the node at position 2 simply pointed to the new element or the new node, and then that new node started pointing to the existing node which was there in the position 3. Okay, so this is how we simply insert the element in between. It is simple as that. It is not like the arrays where if you insert any element in any position, it will simply reindex all the rest of the elements after that particular index, right? So if you insert any element in the starting, then it will simply reindex all the elements after the starting element, right? And same with the like element if you're inserting that element in the middle, right? But in linked list, if you see what it does, it simply started pointing to the new node, and then that new node started pointing to the existing one, and now it is a part of this linked list, right? As you can see here, here also I have inserted a new node, so this one started pointing to this one, and this one started pointing to this one. It's simple as that. That is why it is called like the insertion and removal of the nodes is way more performant in linked list in comparison to the what to say, arrays, right? In arrays this operation is way too costly. So if you have the use case where you have to insert and remove the elements more frequently, then you should go with the linked list, okay, instead of using the arrays. Okay, so this is how like the singly linked list looks like. We will discuss about the doubly linked list also, where this the second element, or we can say where the nodes will know who is the previous element and who is the next element, or it will work in both the directions from head to tail and tail to head. High level overview, right? Now let's quickly do a comparison. Like in arrays we have insertion and deletion costly, as I have said already. In array, if you add any element in the beginning, then all the elements after that particular element will get reindexed. If you are pushing any pop like unshifting any element in the beginning, adding any element in the beginning, so that element will become like the index of that element will become at 0, and then all the elements index will get changed, right? That is what happens in the arrays. Okay, that is why we call it it's costly. So in small data that does not impact a lot, but in case of large data, let's say you have thousands of elements in it, then it is a quite costly operation, right? Adding and removing elements from in between, right? Accessing the elements in arrays is quick because we can simply access by their index. Okay, so that is the advantage we have in arrays. Now let's talk about linked list. Insertion and deletion is efficient. We have already seen why it is efficient, because we don't have any index at all. We don't have to reindex any node. Okay, we simply have to connect the new node with the existing one, and we have to start pointing it to the existing nodes. That's it. We don't have to reindex. We don't have to worry about the size of the data. Okay, it does not matter if we have the 1,000 nodes, if we have the 100 nodes. If we want to insert anything, we can simply insert it without affecting other nodes. That's it, right? So cannot access numbers randomly. We cannot access in numbers randomly the way we used to do in the arrays, because if you access any number, you have to go from the head node all the way up till the node which you are trying to find. Okay, that is what to say, we can say is a cons of the linked list, and everything have a pro and cons, right? So it depends upon your use case. If you are inserting and removing elements from the data more frequently, then you should go with the linked list. Otherwise, if your use case is like where you have to access the elements more frequently, then you should go with the arrays. Okay, so this is how it works. Now this is all about we can say singly linked list. Let's quickly start implementing our own singly linked list from scratch in the next lecture. Okay, in case if you want to take a screenshot of it, you can take a screenshot of it. Let me quickly save it. I haven't saved it. Okay, so you can take a screenshot of this, and you can take a screenshot of this. Okay, and then to access this particular thing, I'll or you simply have to go into the visual algo, guys, right? and then you can search this URL, and then you will find uh, the linked list data structure. I've already shown you multiple times, so I think by now you are already aware like from where you have to go. Okay, so you can take a screenshot of it, and then now let's quickly jump into the next lecture where we will be implementing our own linked list, singly linked list. So this is it for today. See you in the next one.